Okay, so let's do practice quiz 5, number 2a. It says find the general solution of differential equation, and we're given y double prime plus 6y prime minus 7y equals 0. So we're going to use theorem 8 to solve this. Okay. Okay, so we know our solution is going to look like this. Y1 equal m e to the m1x. So y1 prime then would be derivative of m1x would be just m1, so it would be m1 e to the m1x, and y1 double prime would be m1 squared e to the m1x. Okay, let's plug those in up here and find conditions on the m to make this true, to make it a solution, I mean. So doing that we get then, okay, so plugging our y1 up here, so we'll have 0 then because we're going to make it a solution, equals y1 double prime plus 6 y1 prime minus 7 y1. So the y1 double prime is m1 squared e to the m1x plus y prime is m1 e to the mx, and y1 sorry is e to the m1x. Let's factor out the e here then. So doing that we get then, okay, so factoring the e out we get this then. Actually, I just noticed something. I want to change all these just to m's here rather than m1s. I'll explain why in a second. Let's call them m's rather than m1s here. Okay, I think I got one more here. Okay, so changing them all just to m's for now. And notice this guy is going to factor here. It's going to factor as m minus 1, m plus 7. You can check. So let's note that here. So notice it factors as m minus 1, m plus 7. You can check and multiply it out. So therefore we're going to have m minus 1 equals 0 and m plus 7 is 0. So this guy is going to tell us that m is 1. This is saying m is minus 7. So let's note that here. So we have m is 1 or m is minus 7. You call this one, say, m1 and this one m2 if you wanted to. It doesn't matter, I guess. So by theorem 8 then, we'll have the following. The general solution will be given by c1 e to the x plus c2 e to the minus 7x. Okay, so we're done with 2a. Alright, so now let's do 2b. Okay, so let me erase a few things and we'll start at 2b. Okay, so here's 2b. So find general solution again. This time we're given 4y double prime minus 4y prime plus y equals 0. Okay, so let's start with, we know that one of the solutions will look like y1 equal e to the mx. Okay, so y1 equal e to the mx, so that means y1 prime is m e to the mx, and y1 double prime would be m squared e to the mx. So let's plug into differential equation and force it to be a solution and find conditions on m. So doing that we get then, so plugging in, so you'll have 4y1 double prime, so 4m squared e to the mx minus 4y1, so it'll be minus 4, sorry, y1 prime, y1 prime is m e to the mx plus y1, which is e to the mx. Let's factor the e out. So doing that we get then, so we get this, and now the e isn't 0. It means that this quadratic needs to be 0. So you could use a quadratic formula if you wanted to, I guess, here. But you could also notice that this guy actually factors as 2m minus 1 squared. So let me write that here. So it factors like this. Okay, and if this has to equal 0, it means the 2m minus 1 needs to be 0. So let me write that here. So we have 2m minus 1 is 0, so you can see there's only going to be one solution of this guy. So let's add 1, divide by 2. It looks like m is going to be 1/2 here. Okay, so m is 1/2. Since we only have one root, we're going to apply theorem 8, saying we can find the second solution by multiplying the first solution by x. So let me state theorem 8 then. So by theorem 8 then, the general solution is given by c1 e to the x over 2 plus c2x e to the x over 2. So it's pretty much our first solution it's going to be when m is 1/2, so it would be e to the x over 2. And the second solution is x times the first one. So that's the first solution. The second solution is just x times the first solution. So by theorem 8, this will be the general solution. Okay, so we're done with this question. We'll do 2c in the next video, so let's leave it there.